We just you. All right, how you doing? Yeah, it's okay. Not with me. Uh, I'll get a problem. I'll pick up some. Okay, does that make sense? All right. Couple of things. So we have a test scheduled for next week. How does next Friday work for you? I think that's the third.
Push it back a little bit.
It's gonna be okay. Not okay.
I know we leave the door fuzzy, but we have.
Well, if the majority of it's fine with it, you're sorry.
Yeah, we can take it.
Take it or do something like that. Thursday or something like
Yeah.
that. Yeah. We'll probably do a quiz and sometime this week. We'll probably do that Friday. That'd be okay. Quizzes before we and before we get to that, I will write down some of the topics of what we'll be discussing for the exam. Does that make sense? Whenever I write an exam, I have an outline, so I get all the topics. So I don't just favor, just stoichiometry, it's nomenclature. Does that make sense? So I just write down that outline. Seems to help students. And I'm not a very creative person if you haven't figured that out yet. And all it is literally the titles to my PowerPoint slides. That's all it is. Yeah,
And the calculator is something we need to get, right?
yeah. One of these, can't use the one on your smartphone because you know,
Yeah.
AI, artificial intelligence will cheat and all that stuff. Right? So, yeah, I have this cheap little Casio. I paid $10 for it. And I've had it for 4 years, I'm sure, and hope I'll have it the rest of my career. All right. Here's the next problem. Calculate the mass in grams of each product formed when 174 grams of silver sulfide reacts with excess hydrochloric acid. I'll let you, so you're gonna have to balance this. I'll let you start it, and I'm gonna take off and go get the periodic table, okay?
Yeah.
We need a periodic table. Anybody else?
Thank you.
Were you able to balance the equation?
Is it is it two including?
Yeah, so it'll be
Ag2S plus 2 Ag plus Ag.
Were they able to do that? So remember what we're going to do, right? We're gonna go grams to moles to grams. Right? So you're gonna start with the 174 grams of silver sulfide, right? You go to moles. Are you gonna start with what's given, correct? Right? So what else? So we're supposed to bless you. So we're supposed to do this for each product, correct? So we're gonna have to do stoichiometry twice. We'll first do it for the silver chloride, okay? So we'll do 174 grams of the silver sulfide. We want to convert that into moles. So 1 mole of silver sulfide. So we got to calculate the molar mass of the silver sulfide. So 7.9 times 2 plus 32. This gets us a mass of 247.8 grams of silver sulfide. Right? So now our grams cancel. Our grams of silver sulfide cancel. We're in moles of silver sulfide. Now we're going to set up a mole ratio between the silver sulfide and the silver chloride. So in 1 mole of silver sulfide, 1 because there's a 1 there, right? Now 2 moles of silver chloride. And then our moles of silver sulfide cancel out. Right? And now, essentially, the problem's well, this part of the problem's over. Now we're just going to convert it back into grams. You can say then 1 mole of silver chloride, 107.2. Is that what that was? Should be 9. Yeah. Now the mass of silver chloride is 143.35 grams of silver chloride, and then the moles of silver chloride cancel. 2 molecules of 174 divided by 8. And here we get 201.3 grams of silver chloride. Yeah.
So did you get the mass from the first number?
And this number, this comes from the periodic table, and that number comes from the periodic table. Yep. Make sense? Yeah.
The 247 is just it's double
2 silver,
double
1
silver, and then one
sulfur. Yeah, 1 sulfur. Yep.
and you're combining on the reactant side, not the product side.
Well, in this case, what I'm doing is I'm going grams. Like in stoichiometry, you can work from the product to actually the best way to do is actually from the product to the reactant. How much reactant do you actually need to produce so much product? That's mostly how this is done. So it doesn't matter what's reactant side or product side, but what I'm doing is I'm going grams of silver sulfide to then moles silver sulfide to then moles silver chloride, and then ultimately to grams silver chloride.
Okay.
And I do the same, I do the same thing every time I do the same thing.
Yeah,
It never changes.
I guess it was a little lost because I was asking just for each product.
So now we gotta, so we did it for this. Now, the next one is hydrogen sulfide. So why don't you work on doing the stoichiometry for sodium for hydrogen sulfide? Doing the exact same thing, except that this part, this is not silver chloride. This is now hydrogen sulfide. So you're gonna have to start the exact same way, aren't you? Because you have the 174 grams of silver sulfide. If you don't know how to do it, just at least write something down and attempt something, okay? If you leave it blank, then, but just write something, go with something. Even if it's not 100% correct. Get it? So for the hydrogen sulfide, we're gonna do the exact same thing. 174 grams of silver sulfide. My goodness, I thought I brought down the marker, but they're all gone. And now, 1 mole of silver sulfide is 247.8 grams of silver sulfide. Okay. Now, what's the mole ratio between silver sulfide and hydrogen sulfide? 1 to 1. Yeah, exactly. So we'll put 1 mole of silver sulfide to 1 mole of hydrogen sulfide. And once again, our units do cancel out. Now we have to determine the molar mass of hydrogen sulfide. So 1 mole of hydrogen sulfide is equivalent to 34 grams of hydrogen sulfide. So we have the 174 times 34, is that about 247? Now this gets us to 23.87 grams of hydrogen sulfide. Get that? We good? Any questions? In the moles of this cancel off. Now, in the lab this week, you're gonna be doing stoichiometry. Make sure you write this moles of stuff, okay? Most students don't want to write this because they're unsure of what they're actually doing. Does that make sense? Just write it in there, okay? I guarantee Dr. Baldwin and myself will hopefully won't say snarky comments. I probably will, but say, what is this quantity? And so you want to write those units in there. Does that make sense? It really does help you out a lot. We're good? Okay. All we're gonna do today is stoichiometry. It's gonna look a little different. It's gonna be the exact same thing. Everything, nothing's gonna change, okay? All right. There's another way we can, this is really stoichiometry, but it's a mass percent. Right? So if we have a particular substance, right, or a compound, whatever we're looking at, and we want to determine the mass fraction of what makes up that compound, okay? So we can look at the mass fraction, which is going to be the mass of some element in 1 mole of compound, divide a mass of 1 mole of that actual compound. So in this case, we're actually doing sodium nitrate. So what we want to do is we want to find the mass. What percent of sodium nitrate is due to oxygen? Does that make sense? So what mass of sodium nitrate is due to oxygen? Right. All right. Well, how do you erase what don't want to work? All right. So what is the percent of oxygen in sodium nitrate? So what we're going to want to do is this is going to be the mass of oxygen divided by the mass sodium nitrate. Right? And we're going to multiply that. We just leave it as a fraction. We'll leave it as a fraction. It's all right. That's going to be equal to our mass fraction. Okay. Now, do you remember what sodium nitrate is? So sodium is Na. Yep, exactly. Exactly. And nitrate is NO3. NO3. Yep, NO3. Good. You remember the charge of nitrate? -1. Beautiful. So sodium is +1. Nitrate is -1. So we know we have 1 sodium and 1 nitrogen. Very good. Excellent. Now, we're going to do our mass of oxygen divided by the mass of sodium nitrate. This is now going to be equal to 3 because we have 3 moles of oxygen times 16 grams per mole, okay? Divided by, we have 1 mole of sodium nitrate times, so now we we calculate the molar mass of sodium nitrate. 48 plus 14 plus 23. This becomes 85 grams per mole. Okay, so now our moles cancel, and now we're left in grams. So this becomes equal to 3 times 16 is 48 grams divided by the 85 grams. And we get 0.565. So about half, a little over half. So a little over half of the mass of the sodium nitrate comes from the oxygen. That makes sense? Yeah. Get the 85. So the 85 came from the periodic table. So this comes from the periodic table. That comes from the periodic table. So it's just the 23, the 14, and then the 3 times 16 is just 48. Yep, that's right up from. Yeah,
We always just do 16 instead of 15.9.
yeah, you could use 15.99 if you want to. 16 is close enough.
Okay.
You get an hour for the exam, right? So just kind of round up. That's why I'm not really big on significant figures in this class because you may use 15.99. That's just me what you like, and some people may use 16, so the number varies a little bit. I give you a range for whatever that value is. Does that make sense? And in all honesty, the answer, let's say you have a 10-point problem on my exam, the answer is only worth at most 1 point. This is worth most of the points. I've had students that completely forgot calculators and just literally wrote out the problems I gave them, essentially full credit. That's the word. So if you, does that make sense? Yeah, Olivia?
Do we need to bring like a physical copy?
Yeah, 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 I don't know how she's gonna, yeah, yes, you're gonna want. Yeah,
Could we use our phone?
no. Remove the temptation. So, no. You can bring your phone, I just won't let you use it.
Yeah.
Well, one time this wasn't here, it was at a different school, and in that case, I taught classes that were, I think there were 72 in that class. And I remember looking out and saw a reflection off a dude's glasses. I literally saw the reflection off his glasses and kept, you always tell when someone's cheating because always looking at the crotch. That's literally what he do. And his head bent down. I could see the reflection off his glasses and put the phone down. Anyway, no, you can't use your cell phone. I buy these cheap little Casios for $10 at Walmart. That's what I do. All right. I mean, now schools are having to use decimals, right? Isn't that what they're mostly using for calculators? It's kind of decimals, though it's called.
Yeah.
Yeah. My wife uses it. Does that make sense? Is this good? Yes, no? Okay. All right. This still has to do with stoichiometry. It still has to do with stoichiometry. Now, I'm just gonna go up and read a couple of these problems and help. A lot of students say, I don't know how to start a problem. I don't know how to start a problem, right? If I heard that, if I got paid every time I heard that, I'd be a rich man. Well, I'm not quite rich, but I hear it a lot. If you ever see something with excess, you know you don't have to do a limiting reagent problem. Okay? However, if you are given information on both reactants, you're going to have to do a limiting reagent problem, which means you have to do stoichiometry at least twice. All right? So in a limiting reagent problem, remember in a chemical reaction, you're taking two reagents and you're reacting them together, right? You're reacting them together. Okay. And that means that one of the reagents is going to run out first. The reagent or the reactant that's going to run out first, that's going to determine how much product you get. Does that make sense? It's just like shopping, correct? If I were to go to Cabela's, if my wife were to give me permission to go to Cabela's, what's going to limit the amount of fishing equipment I can buy? Money, my allowance I get. I don't have them, but does that make sense? Right. That's going to determine how much fishing equipment I can get. Here, it's going to be the exact same thing. There's going to be a reactant that's going to limit how much product you get. That's it, right? It's the same thing with cooking, correct? My wife made muffins last night. I don't know why, but she made muffins last night. And however much one ingredient she had, that's all the muffins we were going to get. That makes sense? We're going to get any more. So it's going to be one of the reagents or one of the reactants that's going to that is not in excess. It's going to limit how much or determine the yield of the product. The reactant that produced the least amount of product must be the limiting reagent. Does that make sense? So it's going to be the one that's going to produce the least amount of product. Right? All right. Okay, got that in your mind? Good with that? So we're gonna have to do stoichiometry twice, right? Does that make sense? We have to do stoichiometry twice, okay? And we'll do one right after this. Now, there's what is called a theoretical yield. A theoretical yield is going to be that yield which, if everything were perfect, that is how much product we should produce, right? I always kind of compare this to taxes. So when we first moved to Michigan, my daughter was, I think she was 6. And at the time, she was madly in love with pink. And we have a Dollar General in Concord. You know you have a quality town when you have a Dollar General in there, right? Upscale, I'm telling you what, man, it's amazing. So she saw this amazing pink pen, and she's a very frugal young lady. She was even frugal then. And so she got her $1. And I said, sweetie, it's going to cost you more than $1. It says $1, Dad. Then I introduced her to taxes. And at 6 years old, she said, I hate taxes. That's my girl. Right? So you may want to buy a pen for $1, but you have to spend more than $1 because there's some, in essence, we don't want to call it waste, right? Because this state uses all its money to repair the beautiful roads. Anyway, does that make sense? All right. So there's going to be some waste. It's not all going to get converted. And this, a lot of this has to do with the second law of thermodynamics and some other things. Now, the actual use, so the theoretical use, you get this from doing stoichiometry. So this comes from actually doing the stoichiometry. The actual use, you get this from doing the experiment, right? So this comes from stoichiometry. This comes from doing the experiment. You have to do the experiment or this number has to be given to you, right? The percentage of the theoretical yield actually obtained in an experiment is called the percent yield. So our percent yield is going to be the actual yield divided by the theoretical yield. Now, the theoretical yield should always be greater than the actual yield, right? The theoretical yield will be larger than the actual yield because you aren't going to get 100%. Now, if you do get more than 100%, a lot of times it's because your actual yield, that product may be wet. And so you're not actually just weighing the product, you might be weighing some water or maybe some other type of impurity. Does that make sense? It's hot in here. First couple of weeks of class, they actually had the air conditioners blowing like crazy out. This is amazing. And then they stopped it. All right. When benzene C6H6 reacts with bromine, we're going to produce bromobenzene, C6H5Br. Okay. And one of the hydrogens from this is going to react with one of the bromines to give us HBr. Okay. Now, when 30 grams of benzene, this is benzene, and I don't expect you to know that. Well, I give you some symbol, I let you know what the compound is. When 30 grams of benzene reacts with 65 grams of bromine, what is the theoretical yield of bromobenzene? Okay. So how many times do we have to do stoichiometry? Twice. We have to do it twice. We're going to go from we're going to take the 30 grams of benzene and go to bromobenzene. Does that make sense? Then we're going to do stoichiometry again. And we're going to start with the 65 grams of bromine and then go to the bromobenzene. We're going to do stoichiometry twice. That makes sense? All right. Do you think the equation's balanced?
No.
Yes, it
Really?
should be. Yep.
No. Yeah.
Yep, it is. Yep. Yeah. 6 carbons, 6 carbons, 6 hydrogens, 6 hydrogens, 2 bromines, and then 2 bromines. And on the exam, I will tell you whether the equation is balanced or not. So you don't have to spend time doing that. Make sense? All right. And if you don't finish the exam, don't freak out. I mean, there's 130 plus points on each exam. Does that make sense? Go ahead and get it done. Well, don't worry about it. It's not the end of the world. There's 130 plus points. It's only worth 100 points. Does that make sense? Some students freak out, oh no, it's not more than 100 points possible. Okay, all right. So we're gonna start with the 30 grams of benzene. So we have 30 grams C6H6. And what do we want to go to? Moles, exactly. I ask you these questions because hopefully these questions will get ingrained in your mind. And when you're doing stoichiometry, you'll ask those questions to yourself. Does that make sense?
Mhm.
That's why I ask these questions. When I went back to graduate school, that's what I did. When I was studying, I was asking myself constantly questions. What am I doing? Do this. What comes next? What comes next? And I just kept asking my question. So when I actually came to taking the exam, those questions were ingrained in my head, and I just marched myself right through the problems. Makes sense? So if I want to come up with the masses, I'm going to have to look at the periodic table. So 6 times 12 is going to be 72, right? Plus 6 more is going to be 78 grams. Right?
Do you want, like in the question, it says 30 grams. Would you want us to do like 78? I got like 78.1.
That's fine. Go. No, not at all. Not Olivia. As I said on the answer, here's what I'm gonna do, Olivia. I'm gonna just look at how you did this. Does that make sense?
Yeah.
And if that answer somewhat close to what I got, boom, full credit. That's because some people are gonna. Vinny talked about it. If I'm gonna do options 15.99, I just do it as 16. It's an exam. You have a range. That makes sense. Good question. And I show you a lot of grace because you people show me a lot of grace. Now we want to do it. What's the next step?
Mole.
Mole to mole ratio, right?
Yeah.
And we're gonna put the unit that we want on top. 1 mole
Bromobenzene.
of bromobenzene to 1 mole and I always do this because I don't want to leave that step out because it may not always be a 1-to-1 ratio. It may be something different. Now we want to convert this into grams. So it'd be 77 plus. I should know bromine, but 7.9. So 1 mole C6H5 Br is 156.9 grams. Three 5 grams C6H5 Br. Everybody, does that make sense? Any questions? Remember, if you have questions, ask. I've taught you here 8 years. I find SAU students very graceful, very friendly. Don't ever be afraid to ask questions. Just keep asking. That's good. It's different than other places I've taught at. You're blessed. You know where all the numbers come from. Yeah.
The rest confused on where you guys are 156.9.
So that would be the C6H5Br. So I kind of cheated, but if this is going to be 78, I subtracted 1 from it, which would be C6H5. Then I just added the mass bromine to it.
Hmm.
Yeah.
So to find like the 60.35, you take the 30 and then,
Yeah, just multiply the numerator, divide by the denominator.
so then you take 30 times the 1.
Yep, and then divide by 78. Yeah. And if you just multiply and divide, the order doesn't matter. All right, you ready to do the next one? So now I want you to do the same thing, but with 65 grams of bromine. So you do the exact same thing, but you're going to be starting with the bromine, okay?
Okay.
I'll give you 2 minutes. All right. Start with this. Don't ever be afraid to make a mistake. I've learned my greatest lessons not from successes, but from mistakes.
You're still solving for the.
Yep, bromobenzene, yep, absolutely, yep. That's a good question, Vinny. So you always go to the same product. Does that make sense? So you can compare apples to apples. Yep.
Ratio the same?
Yep, everything's 1 to 1.
Thank you.
Yep, everything's 1 to 1, so that's kind of nice. It won't always be 1 to 1.
Yeah, 159, 156.
That will be consistent, stays the same, yep. Yep. Yeah, so
In cases like the first problem we did of the day where you had to find like the mass for each of the I guess products.
Okay.
Will that always those added together, will that be the same
no,
of the?
no,
Oh.
no, in this case, we're just looking for just that one individual product.
I know, like with the, I guess what I was asking was will the mass of the products always be the same as the mass of the reactants?
No,
No.
no, they can differ. Yeah. I think I understand what you're getting at. Cause this mass is clearly not the same as this mass. Am I messing something up? Like one side.
Yeah, that's what I,
What do you mean?
will one side be always the same as the other side? Like,
I'm confused, sorry. We mean the same. In mass or
Yeah.
in terms of moles or?
mass, yeah.
Well. This will always be 30 grams for this problem. This will always be 65 grams. I don't know what you mean by the same. What are you comparing? Masses, moles?
Masses, yeah. It's like-
No, I don't think so. I don't think so. All right, that's fine. That's all. Are we ready? All right, now. One more. For bromine, that's 79.9 times 2. You go up to 59.8.
Mhm.
59.8 grams of bromine. Okay. Now we do the mole ratio. So we have 1 mole bromine, 1 mole of bromobenzene. This becomes now 1 mole of bromine for 1 mole of bromobenzene. Okay. You get 63.8.
Mhm.
What you got? So what is gonna be your theoretical yield? So we have 2 answers. Any questions about what I've done up to this point? What's gonna be your theoretical yield?
60.
Exactly, because this is gonna be your theoretical yield, because we're gonna run out of the bromobenzene before we run out of the bromine. So this is gonna be your. That's gonna be the theoretical yield because it is it's the smallest. So what's gonna happen is if we were to take 30 grams of benzene and react with 65 grams of bromine, we're gonna run out of the benzene first. So we're gonna have excess bromine left over that isn't gonna be reactive. Make sense? So this is gonna be our theoretical yield. The next question asks, if the actual yield of bromobenzene is 42.3 grams, what's the percent yield? Any questions before I erase this? Anything? Yeah,
We didn't use we didn't use HBR at all.
No.
This was
the only,
there.
good comment, the only purpose the HBR would serve is to balance the chemical equation. But yeah, since we're not interested in it, we're gonna ignore it. It's just like shopping, right? If my wife were to ask me to go buy tomatoes, I'm just gonna completely ignore the apple juice, whatever, does that make sense? I'm just. So yeah, and the only purpose that serves, Cooper, is it's just to balance the equation, that's it, so we don't even care about it. Make sense? We have to have it to balance it, but we're not gonna do any calculation. Good comment. Any question, anything else before I erase this? Anything? All right. So this is gonna be the smallest. The percent yield. That's going to be equal to our actual yield. Divided by our theoretical, okay? Now, this would probably more than likely have to be given to you, okay? Because you're not gonna do an experiment in class. You do it in the lab, actually, we do a lot of those tomorrow, but we won't be able to do this in class. So the actual is the 42.3 grams divided by the 60.35 grams. You're gonna multiply that by 100, to turn that into a percent. 1, 2, 3, 4, 70.1. Make sense? Any questions? All right. If you have questions, please ask. Just for sake of time, let's do this one. This one's kind of. Yeah, this one wants to do all the different products. I'm gonna rewrite that, so it's just one product, because that would take forever. This is called the Haber process, one of my favorite reactions. It's what allowed me to grow up in the Midwest. This is a nitrogen reacting with hydrogen to produce 2 moles of ammonia. You can typically tell an equation is going to be balanced if it's got the coefficients out in front. If it's got the coefficients out in front, a lot of times you know that it's going to be balanced. All right. So in this case, we're starting with 100 grams of nitrogen, all right, and 20 grams of hydrogen. So we have information on both reactants. So how many times do we have to do stoichiometry?
Twice.
Twice. There we go. All right. So go ahead and get started on that. And all we're gonna be, yeah, we only have one product, the ammonia.
Where do you get the top one? So you're gonna see
There again?
in each.
You got something written down, right?
And you're gonna.
Okay, good. That starts with that, okay?
And you're gonna multiply.
Worst case,
And then add them together.
write down what's given, okay? So even on a test, I'll give you a couple points on it.
Yesterday.
Right, nothing. All right, we good? Ready to start this? I'm being too impatient. I'll wait a while, right? You just tell me to wait. I'll listen, okay? Jones over there. The back might be didn't be sweatshirt. I didn't see the other name. Yeah, he's Jones there. Yeah, so he's. Just cancel out.
Just so you know, you can turn in your lab from last week in my section, anytime.
Sounds best, no, because. Yeah.
This is just the temperature.
Wait, I think everybody's.
They should. I don't know if they both of them. They should. We good? Got it? Ready? All right. We're gonna start with what's given, okay? We're gonna focus on and start with the nitrogen and go to the ammonia, okay? And we're gonna ignore the 20 grams of hydrogen for the time being. Does that make sense? Just focus on the nitrogen. We'll do the hydrogen later, okay? That makes sense? Don't get confused and combine them. We have 100 grams of nitrogen. 1 mole of nitrogen is 28 grams of nitrogen. So far, so good. And then we do the mole to mole ratio. We see that we have 1 mole of nitrogen for 2 moles of ammonia. And then 1 mole of ammonia is going to be 17 grams of ammonia. Makes sense? So we have 200 divided by 17 divided by 28 equals we still got it right. So import that up to 17. Did you get 121.4 grams? Yeah.
Did you mark it wrong if we wrote 2 moles under 17, 2 moles under the last one and wrote 30
Here?
instead? Yeah.
No, if you wrote 2 and 34, that's fine. No, that should be fine.
Yeah, but you got the same.
Should be fine, yeah.
Where'd you get the 17?
Oh, so that would be nitrogen, it's just, so this comes from the periodic table. And then that comes from the periodic table.
That's just the nitrogen.
Yep, yeah, so nitrogen's 14 and each hydrogen is 1, so that's gonna be 17, yep. Good,
I times it by.
okay. We're good? So now. Bless you, we'll do the hydrogen. Okay. The hydrogen, which is 20 grams of hydrogen. one mole of hydrogen is 2.016. Sorry, it's. If you wrote 2, that's good enough. I was just taught chemistry by an old chemistry professor that did that. So 3 moles of hydrogen with 2 moles of ammonia. Now we do the exact same thing. 1 mole of ammonia is 17 grams of ammonia. So far, so good. 20 times 2, oops, that was it. 20 times 2 times 17 equals that, divided by 2.016 equals that, divided by 3. So in this case, I got 112.43 grams of ammonia. So far, so good. Any questions? Yeah.
So if you don't round anything, the difference is pretty, like I had a difference of like over, it was 113.5.
Close enough.
That's
Close.
okay,
Oh,
like,
absolutely.
nothing
Yeah.
fancy.
Yeah, absolutely. 100%. Yeah. Because we're going to treat this number a little different. We're always going to treat these numbers a little bit different, those masses. Perfectly fine. That's okay. I will give you 100% on that. Because what I do is I look at this. That's what I look at. I don't look at this a whole lot.
Okay.
So this is what I look at. Yes, that's perfectly fine. Absolutely. Yeah.
So if we take the two coefficient of the ammonia for the 2 moles, and we instead do a ratio of 1 to 1 and use 34 point, I think I had 34.8 something. Then do these double ammonia, would that be marked
Then
wrong?
what will you put here?
Yeah, oh, on top you have the full thing, including the double ammonia for your calculation grams.
Well,
It gets you the same answer.
yes, yeah, I do it this way because this is exactly what it means. If I look at the balanced equation, it's 2, I mean, I'm gonna mark it wrong. You want to make sure you don't get that screwed up, right? When you're doing some other kind of problem, get yourself mixed up. But I do the same thing every time. When I go to Walmart, I park my car in the exact same parking spot because I don't lose my car. I do the same thing every time.
Yeah.
This 2 moles of ammonia comes from the balanced equation. This comes from periodic table. This is the meaning of the period of the balanced equation, and this is the meaning of the periodic table. That's why I do it that way. So. If I look the right answer, I'll probably give it to you just because that makes sense. To me, it's just inconsistent with what the balanced equation says and what the periodic table tells me. That's why I do this. So, we're good? Does that make sense? So what is going to be the actual yield? I'm sorry, what's the theoretical yield? What's the theoretical yield? Yeah, it's the 112, exactly. Yeah, absolutely. So the hydrogen in this case actually determine how much ammonia we're going to get. So this is that's the theoretical yield, right? So now we want to find the percent yield. So our percent yield. The percent yield is going to be the actual yield. So that's going to be the 58.75 grams divided by our theoretical yield, 112.43 grams times 100. So in this case, I got 52.3%. So if you're in that 50th ballpark, perfect. We're good? Yeah.
I missed it, but how do we know which one's the theoretical yield?
Is this the smallest, the one that produces the least amount of product? Yep, the least amount of product. We're gonna run out of hydrogen before we run out of nitrogen. That's probably gonna be the actual case in this reaction because hydrogen is expensive. Nitrogen is good from the air. We're good? All right, I'll see half of you tomorrow in lab, and if you have any questions on this, please stop and let me know, okay? All right, have a good day.